All right, Robert Cooper again for data visualization. Today we're going to talk a little bit about the stringr package. Stringr package works with texts, with character strings. It's really powerful and useful. You're going to work with variables a lot of the time where let's say you have a database about movies, for example, which I use in my class from time to time from IMDb, and there's a genres variable in there that has a bunch of different genres of thousands of different movies. Now, that particular variable is kind of messy because it has multiple genres per row in that one variable. So if something is both an action and a comedy and somehow a sci-fi film, it will say action with a vertical line, comedy vertical line, science fiction. That can get pretty messy because the people who originally coded those movies apparently didn't really mind how many genres they were putting into a single variable, because there are movies that have 4, 5, 6 different genres, supposedly. It's not very useful in that format for classification or for comparing, let's say, action versus drama or comedy versus drama, right? It may be good at describing the film and how complicated it is, but eventually you want to get to is there a primary field, a primary genre, and maybe a secondary or a tertiary. So anyway, something like that is where, or you've got a list of presidential executive orders, and you're trying to look for executive orders that deal with, and their text descriptions of these orders, right? And you want to think about what kind of executive orders deal with land management, right? Like the expansion and contraction of federal lands or something like that. Stringr functions would be very useful. Stringr functions in conjunction with what are called regular expressions. Now, regular expressions are quite powerful. They're simply text strings that describe patterns in character or strings, text, that you're looking for. And this means alphanumeric. It could be both letters and numbers in this case. These are things that are common to programming languages. And now, certain characters require what's called an escape, in this case, a backslash, before you try to locate them within quotations, because there are certain characters that are actually useful in computer programming. They actually have functional purposes, right? And that's true in R as well. So you need to be able to use escapes in order to actually locate the character inside an observation in your variable, as opposed to R thinking it's actually in its functional format, like the colon, the semicolon, plenty of others as well. Like those are just examples, right? Now, stringr has a really good cheat sheet. I don't know if you know about RStudio cheat sheets. People from my workshop and my course should know about them, but this is available. It's a really good resource to use to figure out where you need to go, which version of a stringr function is the right one for you, because they suit different purposes and they produce different outputs, right? So that's what you need to worry about. You need to worry about what do I need to do and what kind of output do I want? What's the input and what's the output? But we will talk about a few of them in this particular video. Okay, so I have created, as a first example, a vector of nonsense. I'm calling it garbage because it's literally a bunch of garbage, character-wise anyway. There are a couple of pieces inside it that are useful, but the rest of it is just nonsense and doesn't even need to be there. This is a little bit of an exaggeration of how bad sometimes things are coded when other people do it, or people coded something in the past before there were good standards for how to code, maybe, or they're just sort of insufficient in their handling of a job, right? But this will demonstrate the purpose, if nothing else. Okay, so I've created this code here. It says garbage, and then I concatenate a series of observations of text. These are just character strings with a bunch of nonsense in it. And just to make sure that it is as character, I've wrapped an as character around it, so that I know that it's a character string. Okay, so I'm going to go ahead and run this. It is a vector of nonsense. Okay, so now we're going to make sure that it exists. It does. And it's just a few observations together in a vector of nonsense, right? Okay, so now I'm going to slightly reform that and put it in a different object. I'm going to make it a data frame. So in this code right here, I say take garbage, which is right here, call it garb, and put it in a data frame, and make sure the strings don't automatically get returned into factors, because depending on the function, sometimes you may encounter, like when you're importing data into R in the read.csv function, if you're not careful, a variable that is a string variable may automatically be turned into a factor, and it might screw up a lot of things that you're doing, because you won't know it unless you specifically ask for the class of that object. So I am going to turn this into a data frame now. And then you see this semicolon here. I don't think I've introduced this in class, but what this does is it breaks the line. It allows you to execute two commands at once, two functions at once. So I'm actually creating a data frame called nonsense that takes garbage and just renames it garb as a variable. It makes sure that it is not changing it from a character string to a factor, and then I break line and I say show me print nonsense. Okay. All right. So there we have a one variable data frame with a bunch of gobbledygook in it that I've called garb, and the data frame is called nonsense, and the variable is called garb. All right. Now, let's say that we want to start extracting some patterns from the strings. Regular expressions will help me do this. And I'm going to reference the cheat sheet again, because it's super useful, because the second page of the stringr cheat sheet talks about regular expressions. If you look on the second page of it. So right here in this column represents the strings that you're trying to find, you're trying to match. Okay, so let's say that you're trying to find backslashes and remove them or do something with them, right? You want them for some reason. Regular expression for that has an extra backslash for the escape, and then you have to do that double in stringr in R to actually find it, and you do it in quotations, right? But let's start with something a little bit simpler and talk about letters or numbers. Let's say I just want to find any instance of a single letter inside a string variable. Here is the category. We can say any letter. The regular expression for that is 2 hard brackets with 2 colons and the word alpha, lowercase, inside. Okay. So right here, we've already talked before about the pipe operator, so I don't need to explain the pipe operator, hopefully. We're starting with the nonsense database here, and I'm saying make a new variable called garb2 that simply extracts all the patterns from garb, so that's this down here, that contain any two letters in sequence. Okay, so because I have this in quotations and I have the alpha for one letter, the alpha for another letter, that means show me any combinations of two letters in a row from garb down here and extract them all and get rid of the rest. All right, that's what this particular stringr function, this is the stringr function. Remember, you have to use this inside something like a mutate. So I'm going to run this, and it's going to extract any patterns of two letters inside the stringr function. Pretty cool. So it goes through. So you see here, it said, okay, the first pattern I found was JL. The next one I found was FE, etc., so on and so forth. Okay. Now, let's try a different pattern. This particular video, let's get rid of that. In this particular video, we're talking, I'm presenting this video for ICPSR students. So let's look to see if there are any patterns inside garb that say the word ICPSR. And this time I've changed the function from string extract all to string detect. And let's run it. And so it's going to mutate. It's going to make a new variable called ICPSR. And then this is just going to detect whether the garb variable here contains the ICPSR pattern. Okay. It's looking explicitly for lowercase ICPSR. Now, I suppose it would be a good example to do something like this. What do you think is going to happen when I do this? I've changed the lowercase to uppercase. Oh. On the wrong one. All right, let's try it again up here. You see, it went from all falses and one true to all falses because it's very case sensitive. You can fix that, but it's case sensitive. So it's very explicitly looking for lowercase ICPSR here. When you look at it, you see somewhere in the fourth observation in the variable garb, there is an ICPSR. Okay. And just to prove it, we can go back to the string extract all and see now it has sucked that right out of this particular string and put it in a new variable, but kept nothing else when there was no such pattern. That's kind of cool. That's very powerful. This is not only is this a good way to clean a string variable, it's also a good way to identify patterns, right? So if you want to do some text analysis or something like that, stringr becomes very useful. Okay, so I'm changing it up a little bit more. I'm going to keep the string extract all function here, but I'm going to actually go to 5. I'm going to do a combination of a very specific pattern with a generic rule. So I'm going to make a new, again, so in my regular job, I also work at Dartmouth, so that's why the variable said Dart. So I'll fix that to ICPSR. We start with nonsense, then we make a new variable called ICPSR, and this time we're going to string extract all again. And the new pattern is explicitly lowercase ICPSR plus 1, 2, 3, 4, 5 letters of any kind. Okay, let's see what happens. Lo and behold, there was a pattern. in the fourth observation that said ICPSR rules, because in fact it does. But that's a pretty powerful thing to be able to do, to say I want to look for a specific pattern followed by a generic pattern, right? And this is just one of a bunch of different examples here in these regular expressions. I'm going to show you some more now. Let's say that we want to get all the weird characters out. Okay. All right. I'm going to first, as you can see, go back and look at garbage. You see there's a bunch of weird characters, especially in the second, also in the fourth, but especially in the second observation. See there's semicolons. Let's say I want to get rid of the semicolons. Okay. Another function inside stringr is called string replace all. And so what I'm going to do with this is I'm going to make a new variable called clean. And we're going to use string replace all, find all the patterns with semicolons, and then replace them with a thing. And in this case, I'm telling it nothing. So you see the quotations with nothing in the middle means just get rid of it, right? So we're going to run it. And if you compare from left to right, you can see that the semicolons are now gone, right? Over here. That's great, but there's still other gobbledygook to get rid of, right? You can get rid of multiple patterns with a vertical string with a vertical line, and that's what I do in this next line. So this will take a little bit of explaining, but I hope the logic is starting to make sense to you. So we start with nonsense, we mutate, we make a clean variable, we're going to replace all the patterns we find. And you see this hard bracket, and then inside the hard bracket, we have these vertical lines happening right here. These are saying find all of these. This is this or this or this or this, etc., right? Okay. We are looking for semicolon, period, left bracket, right bracket, and parentheses. So you double backslash the semicolon, then break with a vertical line. Double backslash period, then break with a line. Double backslash left bracket, then break with a vertical line. Double backslash right bracket. That's the logic here for these regular expressions. And then replace all of them with nothing. So if this is written correctly, and I hope it is, then the clean variable should now get rid of all of these. And if you look at it, we are down to nothing but alphanumerics over here. We have gotten rid of all the gobbledygook, punctuation, weird characters over here. So that was successful. So that's a really powerful thing to learn. So I encourage you to learn regular expressions and lean heavily on the stringr package when you do that. All right. The last example for this video is going to be a really cool, I mean, you know, I think it's pretty funny, version of a stringr function example using Mad Libs. And it's kind of in a silly way, but you can make it as fun and as different as you would like. I'm making a Mad Libs, and we're going to replace things randomly based on sets of words that we have preset. Okay, so first I'm going to talk about the Mad Libs. It says, there once was a blank named blank. She was very blank and enjoyed blank with her friends blank and blank. Clearly, they would be friends forever. I think I changed it to 3 friends, so let's change it to they. All right, so we need a vector of words for the game, so I've preset some names, nouns, verbs, and adjectives. I didn't put that many in here, but it's pretty easy. So names, I picked some weird ones: Thor, Athena, Snoopy, Garfield, Johnny. Don't ask me why. Nouns, I chose animals. Monkey, dog, rabbit, banana, slug, snowy owl. Again, no rhyme or reason. Verb, skateboarding, parasailing, snorkeling, sleeping. Apparently, it's summertime and I'm missing outdoor activities. So, the first three are maybe a subconscious choice about wanting to be outside. The fourth one is what you do instead when you are depressed about not being outside. And then adjectives. Don't ask why, I don't know. So you got to make sure and execute all four. I'm just going to redo that real fast. And then I've created a sampler. Hard brackets let you choose one of the patterns. And so I want to... So start with the pipe. We're going to do string replace. And not string replace all, because we only want to replace the specific one that we're referencing. And then the replacement is not in quotations here, but it says sample noun 1. Now this is a new function for probably some of you, most of you maybe. This just means it's a random sample from a vector. The vector in this case is the noun vector up here. And as you see, all the observations are in quotations. So when it actually executes the sample function, it will be in quotations. And I tell it to only sample one time. Right? So this line says, string replace sample from blank one time. That's what this says. And then pipe, and then do the same thing for the adjective. Same thing for the verb. Same thing for the two different names. And then for the noun. So this should sample and replace all of the just blanks with words, and we should be able to get something pretty interesting. Maybe, hopefully, kind of funny. There once was a banana slug named Johnny. She was very orange and enjoyed parasailing with her friend Thor the rabbit. Clearly, they would be friends forever. Well, isn't that nice? All right, let's run it again to see if the randomizer actually works, which of course it will. There once was a dog named Thor. She was very fluffy and enjoyed, again, apparently, parasailing with her friend Johnny the monkey. Clearly, they would be friends forever. Okay, so I hope you see how stringr with the replace, the, replace all, the extract all, and the detect is an incredibly powerful package, especially in conjunction with regular expressions, but also you can do things like this that are really interesting and fun, and I hope that it helps you understand what stringr is all about. All right, that's enough for now. See you later.